Hello everybody, welcome back. In this video, we shall look at a very interesting game called the Snake game. Right now, this is a very popular game, and also it turns out that this is a great game to build in Scratch because using this game we can learn a number of new things about Scratch. So let's get started. Right, we'll do this in two parts. First part will be about the movement of the snake head. We'll be using, this obviously the snake game. We'll be using lists, direction, and so on, and in the second part, we will look at how we use cloning, broadcasting, and lists together to create a very nice effect of snake body getting extended. So let's get started. Let's just, kind of see what we are building. So here is the game, right? So, I've got this snake head, which when I click the flag, moves around, and I have to use my arrow keys to eat the apple, right? Now notice that whenever the snake eats an apple, its tail extends, right? So it gets an extra tail, and now actually this is happening, as we will see later on, by using cloning, right? In fact, we are using cloning, broadcasting, and lists in a very smart manner in this game. And like I said, this is a very nice game to learn a lot of those features, right? So this game is very interesting. However, let's say if I go and hit the edge of this boundary, at the edge of this platform, then the game ends, right? The other way the game ends is that if the snake goes and eats its own tail, right? So that's how the game goes. So let's start building this together. Like I said, we'll do the two parts, right? So this will be the first part. Basically, I'll get rid of my cat sprite to start with, and I'll first build a background, right? So that part is simple. I'll just go and say paint a backdrop, right? And all I'll do is, I'll keep it very simple. You can make it more fancy. You can create a very, like, some kind of pattern on the background, but a simplest background would be just make it say a green color, a little bit high green color, and just build a rectangle. Maybe make it a little smaller. So make a rectangle and just fill it up with green color, right? So this will be like really the simplest background one could think of, because snake is kind of in a garden and it's moving around, right? So we will use this as our backdrop for this game. Like I said, you can be more fancy, you can be more creative, and do many more things, right? For example, you can create some kind of pattern which looks nice, or you can look at some other color, and so on and so forth, right? But for now, green background should be fine. Yeah. Now we will create the snake head sprite, right? So what I do again here is to go and say choose a sprite, but presumably there's no sprite which directly meets my requirement. So I go and choose paint a sprite, right? And in this case, maybe I'll use, let's say, a brownish color, right? So make it yellow, and then a little bit brownish color, maybe. Oh, sorry, somewhere here, yeah, orangish brownish color. Let's say it's fine. I mean, exact color doesn't really matter, but let's say I'll use this color. And now I will, what I do is that I'll just bring a rectangle of that shape, right? So once I build a rectangle, the size can be reduced a little bit, but I do try to make it in the center. So I basically go and align it again, right? And I can zoom in a little bit now once I know it's aligned. Now I use this particular block, which is, the arrow with the dot in front, right? So I use that to give it a little bit of a shape, right? Although I don't recommend you making it too wide, but it looks nice with a little bit of a shape, right? So I can create, let's say, a shape like this, right? And I can maybe reduce this a little bit, right? Again, you can be quite creative here. You can even, choose not to do this. You can do, let's say, something like this, but I create a snake head which kind of looks like a snake head, let's say, right? And also to give it a sense of eyes, so I'll go here and I'll create two circles, so that become like my snake eyes, and it just looks nice, right? So I'll go and select this again, or maybe I'll just draw this once again here, right? Again, none of this needs to be like exactly precise or something like that. It's up to your imagination, right? In fact, you can also look in the Scratch platform. You'll see people have pretty nice ideas you can get from there, right? So use your creativity here. Make what you really think looks nice for you, and that should be fine, right? So just align these eyes a little bit, and I think this is good enough for now. So this becomes my snake head, right? I will so I'll just call this snake head. Now I will go and create one more sprite, right? So I'll go and paint one more sprite, and once again I will take the same color, right? And I'll just say maybe start with a rectangle, and rectangle looks rather large. I'll again center this thing nicely. So centering is important because we are going to use go to command later on. If it's not centered, then there'll be an issue to align properly with the snake, right? So centering is important. Size can be maybe adjusted a little bit. Now I again zoom it in a little bit, and now I'll use this shape to give it a little, oops. So I'll use this to, sorry, I can move this here. This is centered. Now I'll use this particular tool, which is an arrow with a dot. So that lets you distort this thing. So I'll distort this a little bit to become like a, a little bit like a ball, right? Once again, this is not compulsory that it must be in this shape. You can use your imagination, you can use your creativity to, in fact, this has come a little bit oblique, but it's okay, right? So I'll do this, and now I've got my snake head and my snake body. So I'll rename this sprite one as snake body. Now a lot of students ask me this question as to why did I keep two separate sprites for the head and the body? Why not a single sprite with two different costumes? That's actually a good question, but it turns out that we want to implement a feature where when the snake head touches the snake body, right, it also disappears. The game ends, right? So once there are two separate sprites, it becomes a lot easier for us to build that feature, right? So that's the reason, that's primarily the reason I've taken it this way, that I've put snake head as one sprite and snake body as another sprite. There may be other implementations. In fact, I've seen games where people put it in the same sprite at different costumes. However, I don't think those games implement that feature where snake touches its own tail and it disappears, right? So we will implement that. Hence, I've put it in separate uh, a separate sprite, and also it keeps the code somewhat neater and somewhat easier to understand what's going on, right? So I prefer this. Now, with this done, I'm going to start the coding part, right? So let's make a snake head a little bit small, right? Maybe the snake body, we can move it away for now, right? I'll make the snake head a little smaller. Let's say make it about 50%, right? Again, it doesn't really matter. It is what you like, right? So maybe snake body can be made also say about 50%, because the two we know kind of aligned, right? So we want to kind of align later on. Probably 50 also looks a little large, so we can make it say 40%, right? Now this is something you will have to try, you will have to fine tune in your own code, right? But here's the idea. The whole idea is that snake body should look proportionate to the snake head, right? Should not become much bigger than the snake head. At the same time, snake head should not become much bigger than the body. So these two should be in proportion, and you just adjust them this way, right? So what we do now is that we go to the snake head and we start to give it some code which lets it move around, right? So this code is simple. We start with the favorite block. When flag clicked, oh sorry, I'm in the snake body, so I should go to the snake head. I say when flag clicked, right? Uh, I want the snake to start pointing to the right side, right? Pointing the way it is pointing. So to ensure that, I'm going to use this block called point in direction 90, right? Now, what does this really mean? We have done this in the past when we did the ball movement game, right? But it's very simple, really, right? You can use Scratch gives you this arrow, so which is very helpful in case you do not know yet the notion of angles and so on and so forth, which you might learn in a future date. But Scratch gives us a way to figure out which way it's pointing, right? So when I say point in direction 90, it's really this arrow, which is what we are seeing here, right? So now if I were to do, let's say, point in direction 180, this arrow will be downwards and the snake head would turn downwards, right? So for now, we will want to start it in direction 90, and we'll look at this more closely a little later. We'll also send it to 0, 0, so that it goes right in the middle when the game starts. So the snake goes here. Thereafter, it's very simple. I'll just say, I'll go to the control block. I'll say forever. Maybe I'll say move, let's say 10 steps, or it could be 15 steps. And also, I'll give it a little bit of weight, right, to just make it sound a little, somewhat like a step movement, right? And that just looks nice, right? So if I did this, for example, let's see what happens, right? So we see that the snake, it's just kind of moving. Oh, I made the weight too small, so it moves a little too fast. It's hard to play, right? So I'll just make it 0.1 second, right? So then what happens is snake is moving, and of course that's all it's doing right now, right? It goes to the edge and it sort of stops there, right? You can, if you, let's say, made this move 15 steps, yeah, of course it will move faster. It'll take bigger steps. You can also, like we just saw, we can play with this weight. In fact, I've come across games on the internet, on the Scratch platform, where people change these numbers as the game goes along, right? So as the snake becomes longer and longer, probably they can make it faster, they can change the wait time. So these are elements you could add to make your game a little bit more spicy, a little bit more juicy, more interesting to play. But the basic concept remains the same, that snake points in a certain direction, in this case 90. moves certain number of steps and waits for a little while, right? So that creates a little bit of step movement and looks good. Okay, so now moving forward, we will now do something very, very important. Right now, notice this game is all about the snake body following the snake head, right? So, snake body must go to the place where the snake head is going. And since snake head is moving quite, let's say, let's say, randomly, right? Because it's moving based on the user's arrow presses, right? So, we will build that part in a moment. But before that, I am going to introduce two lists which can keep track of where the snake head is going. Right now, this is very, very important because without lists, this game will get extremely complicated to build. Right, so lists give us the power to build this game, right, in a nice, neat way. Right, so what I will do at this point of time is that I will add two lists. First list is called, right, let's call it, say, X positions, right? So we can let it be for all sprites. So we say X positions, and similarly we make a list called Y positions, right? So we basically intend to store the X and Y locations of the snake using this list. Okay, so that's the whole idea, and let's see how we do this, right? So obviously initially they're empty, but as I've told you many times in the past, that it's always good to delete lists in the beginning, right? So I go and say delete all of X positions, delete all of Y positions, right? So that will ensure that the when the game starts afresh, when the flag is clicked, the the X and Y positions are totally empty. There's nothing stored in them which could potentially disturb your game, right? So we start with this. Now comes the important bit, right? So what do we want, right? We really want that this X and Y should store where the snake head is going. Okay, so we have two choices. We can obviously add elements to a list, right? So we have done this before. Remember, in the memory game, wherever the character went, we added that to the list, right? However, here we'll do something different. We will do something called insert element. Okay, so insert element is right here, insert thing at certain position of X positions, right? So what we will do is we will let it move, say, 15 steps. Let's say in this case is 15 steps, or maybe for this illustration, we'll make it 10 steps, right? And I will say insert the X position. So where do I find X positions? It's in the motion section. This X position refers to the snake head. Insert X position at one of X positions. Right now, this is important. So what this is doing really is that it is taking the list X positions and it is inserting the new X position on that list at position number one, which means that the first element of that list will be the present X position, right? And similarly, we'll just duplicate the statement and we will go and oops, so we'll duplicate this. So yeah, I'll duplicate this and maybe just put it here. Okay, this is clumsy a little bit. Okay, I got it now, right? So I'll put this here and I will, I don't need two weights here, but maybe I'll just put one weight here, right? And intentionally I'll make it a little large so that we can see what's going on, right? In fact, later on I'll also show you an animation on what's going on in this list. But before that, I must make sure that the Y position of the snake is stored in this list called Y positions, right? Notice here we are doing insert something at certain number of X positions and Y position, and that certain number is in fact one here, right? So what we will do now is that we will do, we will just try to study what is happening on these lists. And I've, for that reason, let's me put even larger weight. Say maybe I'll make it 3-second weight, right? So that gives us ample time to look at what's going on. And immediately after this, I will also show you an animation on how this list populates. So the reason I'm insisting so much on this is because this list is the backbone of this entire game, right? If this list is not happening correctly, if this list is getting corrupted for some reason, then the entire game will go wrong, as we will see later on, because this list is what will keep everything together in this game, right? So these lists, actually, to be fair, to be more clear, yeah, X positions and Y positions. All right, so let's see this. So when I do, for example, when I've got these, let's put this here, X positions and Y positions. Let's put them side by side. for the purpose of this illustration, right, I will make this wait very, very long. So I'll make it 5 seconds so that we have ample time to look at what's going on with this list. So, here snake moves to 0 10 because it moves 10 steps, and notice x position is 10, y position is 0, right? Next, snake moves to another 10 steps, which means snake goes to 20 0, and notice the second position is 20 0. Third position now is 30 0, then 40 0, and so on and so forth, right? So basically what's going on is that the last position that the snake is on, right? So the present, basically this position that snake is presently on, right, will end up on top of this list. The previous position will be just one before this, second element. The position before that will be the third element. The position before that will be the fourth element, and so on and so forth, right? So that's happening because we are using insert something at x positions and y positions in this list, right? So this is an important point. This list is storing the position of the snake head in a sort of reverse order. So the latest position, which is let's say that which is the position presently the snake is on top of this list. All right. Next position where the snake was just before it reached this position will be element number 2, and so on and so forth. And this is happening because we are using insert x and y at one of x positions. Now this is very, very, very important. If we had done add, right, let's say we had done add x position, then exactly reverse would have happened, right? The oldest position would have been on top, the second position would have been on second position, the last position, which is the present position, would be on the last, which is the, let's say in this case, 5, right? So this is important. We are doing it in a reverse manner because of this insert, right? So what we will do is, let us give snake some code to turn around, and then I'll show you an animation of what happens on this list so that it becomes a little bit more clear, right? So we'll revisit this point. But for now, let us give some code to our snake to turn, right? So what we want really is, notice in this game, when the snake is moving around, when I click the up arrow, snake turns. However, let's say the snake is going down and I click the up arrow, I do not want the snake to do an about turn, right? So when it's, for example, it's going down, I do not want it to turn and immediately go back onto its own tail, right? So I just want it to turn wherever I want, basically left, right, or become straight. However, I do not want it to do any kind of an about turn, right? So we will do that. We'll let this x and y positions be here. So we will just write a little bit of code to ensure that happens, right? So what I'll do is I will say when flag click, all right, uh, go to control, go to say forever, right? And this part we have done before. I'll say if, let's say if key, let's say I say if key, sorry, not this. I'll say if key maybe say up arrow pressed, right? So I want the snake to point upwards when the up arrow is pressed. So the simplest thing would have been to say that, okay, when the key up arrow is pressed, uh, let's say I will say point in direction, right? So go to motion and I'll say point in direction. Again, use the arrow here. So when the up arrow is pressed, I want it to go and point in this direction, right? So if I did this, then what happens is that I will, the moment snake is moving up, I go and press up arrow. Notice my snake has started pointing upwards, right? Now there's a 5-second wait. That's why it looks very slow, but my snake is pointing upwards now, right? Now, remember that I also set a condition that I do not want snake to do an about turn, right? Which means that if it is already going up, I do not want the down arrow to be pressed and immediately having the snake turned. Or let's say the snake is going down. I do not want somebody to press up arrow and see that the snake has completely reversed its course, right? So to prevent that, what I will do is I will add one more condition to this loop, which is basically another if condition. So I'll say if, let's say, if the present direction is not 180, right? Remember 180 would be exactly downwards. So what we are saying is, in case the snake is going in this direction, don't do anything. If it is not going in this direction, then turn it around back to 0 degrees. So 0, which means basically upwards, right? So I will use a condition called if not, right, and direction equals to 180. So basically uh, not means it is not, right, some condition which is not true. So basically I go here and I say direction So if the direction is not 180, which means 180 would mean that if the snake is going totally downwards and do not do anything, otherwise just turn it towards the top, towards upwards, which is point in direction 0, right? Now one question that you might have at this point of time is that why did I use when flag clicked and forever here, right? Why did I not use when the key up arrow is pressed, right? In fact, that is also correct. You could do that because snake is anyway moving. But I chose to do this because I do not want my snake head to change its position once the game is stopped, right? If on the other hand, if I did when, let's say, up arrow press, when down arrow press, then the game might be over, but snake head will still change. That's just my personal choice. It's not wrong. You can also do when up arrow click or when down arrow click and so on and so forth, right? But the this more important thing is this particular condition which is preventing it from doing an about turn, right? So let's just do this for all the turns, and then we can come back and look at what it's doing, right? So I'll duplicate this, right? Let's say I duplicate this time I'll say when key down arrow press, and if the direction is not 0, which means if the sprite is not going vertically upwards, it's not going upwards, then change the direction to 180, right? So this will basically, like I said, just prevent an about turn. I will duplicate this again, right? I can say when key right arrow press. So if key right arrow press, right arrow basically should take it to the 90 degrees, right? Which is remember this direction. However, however, I want to make sure that the direction right now is not exactly opposite. So I'll say if direction is not minus 90, then make it 90. And finally, I can put, let's say I duplicate this once again. I can put if when key, say if key left arrow press, if direction is not 90, then point in direction minus 90, right? So all this really just to make sure that the snake head does not do an about turn, right? So just just for this purpose. One more thing I want to highlight here is that I could actually put them this all in one condition, in one forever loop, but for the sake of clarity, for the sake of readability, I prefer to do them separately. And in fact, it may be a good idea sometimes to add a comment in one of these, right? So for example, I can say add comment, and I can say, say, let's say left turn, right? Or something like that, right? Left turn. So that makes it easier for people to understand what's going on in a code, right? It's just a good habit to do a little bit of commenting. Sorry, I removed it. So I'll add a comment, say left turn, right? You can add some comments onto your code, and that actually makes the code much more readable, even for you later on when you want to, so you can let it be as it is. Yeah. Now, so in fact, if you want, you can add one more comment here. Let's say add prevent about turn. So prevent about turn, right? So that's why we are doing all this, and it will help you later on when you look at your code or somebody else looks at your code to understand what is it that you're trying to do here, right? So anyway, coming back to this code, now I have got my snake moving, right? So just to illustrate this whole thing, maybe for now I will, I'll just, let's say, hide these two lists so it becomes easier, and I'll make this back to something like 0.1, right? So when I do this, now my snake is moving in the right direction. When I press the up arrow, it turns. Right now, if I press the right arrow, it doesn't do anything because I was already going in the left direction. Now, if I press the up arrow, nothing will happen. But right now, for example, it's going right. If I press up arrow, it turns left, right? If I press right arrow, it starts pointing right. If I press right arrow again, it points downwards. If I press up arrow, nothing happens. If I press left arrow, this happens, right? So basically, snake is now moving quite nicely. It is turning also, but it is not doing any about turn, right? So now let's see. Now let's go back and see our lists little bit carefully once again, right? So what I'll do is once again, I'll go back to 5 seconds here, and I will add this, so when I do this, see what happens. Okay, so snake is moving right. So the first position was 10-0, then it went to 20-0, then it's going to go to 30-0, right? It went to 30-0. Now let's say I did a right turn, right? So what will happen is it will basically have next position will be 30 minus 10, because now I'm keeping the same x but going down in y. Then 30 minus 20, that's where the snake right now is. You can actually corroborate from here. 30 minus 30. Let's say I turn again, then I will get 30. I'll get 40 minus 30 because x has increased by 10, y has remained the same, right? So this list is really containing the latest position of the snake head on top on position number one, and every other position in the past in a certain order, right? So let's just see this once again using a simple animation that I've tried to create, because I thought this was important. So here in this one, I'm going to tell you about the evolution of the x and y position. So this thing has become a bit distorted, but never mind. So for example, the game starts, the lists are empty, the sprite is at 0 0. Let's say I go one step right? So once I step right, I'm taking 10 points to the step, 10 pixels. So I move 10 steps basically, right? So when I say 10 steps, one step really means 10 steps here. So the list becomes 10 0. That's because x position is now 10 and y position is 0, right? If I take another 10 steps, which happens by itself in the code, so what happens is that I will get one more step to the right? And this time round, I will be at 20 0. So because I'm using insert, remember, so what will happen is that 10 0 will remain, wherever it is. So 10 0 is here, it will remain here. The new position will be inserted at 20 0, right? Now let's say I go one step down, right? So remember, as I showed you, I went 20 minus 10. The reason that happened is because x remained the same. So x is the same, y has gone down by 10, right? But because again of insert, so what happens is 10 0 remains here, 20 0 remains here. The new position, which is 20 minus 10, gets inserted right on top, right? And so on. So if I did this, say I went one more step, so 20 minus 20, I will have 20 minus 20 here. Next, if I did this, say I took one step right, I go to 30 minus 20, the list will contain 30 minus 20, 20 minus 20, and so on and so forth. Notice by this color coding, it is kind of obvious that the the very first position that the sprite went to is always at the bottom of the list. The last position where the snake head is always on the top of this list, right? So and that's the whole logic that we are using in this program. We'll revisit this, but the salient points are these, right? These three, that the latest position gets stored on top of this list since we are using insert. The second item on the list is where the snakehead was just before it reached the latest position. Remember, snakehead is presently at 30 minus 20. The second position is 20 minus 20, where the snakehead was before it reached. And likewise, you can just trace back and see for yourself, right? So the third position on the list is where snakehead was two steps earlier, right? So basically, if 30 minus 20 is present position, two steps before this it was at 20 minus 10. So even though it turned, it did whatever, but this position has been recorded in this list. Okay, and this is important. We will revisit this point when we start doing the cloning and so on and so forth, right? So everything is set up. Snake is now moving nicely, the lists are set up correctly. Let's just now introduce the apple's food, right? So for now I'll go and hide these lists, and also I'll make this again to 0.1 seconds, right? So I'll introduce apple's food here, and for this purpose I'll just use a simple apple sprite. Now you could be more creative, you could use other sprites, right? In fact, if you are adventurous enough, you could do different kind of food, right? So probably say apple, mushrooms, or anything, right, which have different effects. So in this case, apple gives it maybe, let's say, one extra tail. Maybe some other fruit can take away the tail or something like that, right? So you can do many things, but this is a basic whole concept, right? So we will now, let's say I'll resize the apple a little bit because it can't be so big for the banana. So this size looks just nice. I made it 30% of whatever it was. Now remember, the apple must go randomly into the stage, right? But I do not want apple to go very close to the edge, right? And why is that? That is just because I do not want the snake to touch the edge in an effort to eat the apple, right? Now if the snake goes and touches the edge, my game is supposed to get over. I do not want it to do so when the apple is, is also on the edge, right? So to prevent that, what I will do is that I will basically, give it a little bit of code to make sure that apple is randomly placed, all right, but it never goes extremely close to the edge. Okay, so that's what I'll do. And how do I do that? So basically I'll say, it's kind of similar to what we did in the game where we had a hero that we had to spot as hero was moving around, and once you click the hero, everybody else went to a new position. So something similar, right? We will say broadcast. When flag clicked, I'll say broadcast, let's say a new message, and the message I will call, let's say call it new position, so it's easier to read. Oops. So I'll say broadcast message new position. Okay, so I'll broadcast a message called new position, and here I say when I receive new position, right? So when I receive new position, I will go and put, I'll say go to, right? So if I could have put go to random position, but then I do not control where it goes, right? So sometimes it might go very close to the edges and so on and so forth. So to prevent that, I will use go to X and Y. However, for both of these, I will put a random number, which is pick random. Let's say maybe between say minus 200 to say 200, and for Y as well, I'll put duplicate this and I'll put go from say minus 150 to 150. Okay, now what this will do is that it will definitely make sure my apple is going to a new position, but it's never going too close to the edge, right? In fact, this is one way you can also reduce to, if you want to make the playing arena much smaller than the full screen, right? So you could maybe define a border. You can probably create a border here, like a which can be a sprite or a color, and you can end the game when touching this color, right? But for now, I'm just doing it when touching the edge, so I'm just making sure it doesn't go very very close to the edge, right? So that's something seems reasonable, right? Now the apple code is fairly simple. Basically, I'm going to use the touching event to figure out if it has been eaten. So I put when flag clicked, again I put it in a separate you know loop, right? So I'll say in the control, I'll go and say forever, right? When flag click forever if touching apple. So go to control, right? So I'll go to the yeah, so if let's say, this is very, very standard. We've done this like in the catch game, in the maze game, and so on and so forth, right? So I'll say if touching snakehead, right? So, I'll say touching snakehead. Then what I want is that I want the apple to go to a new position. And what I can do for that purpose is, just duplicate this thing and put it here so that it will take a new position. Remember, one user broadcast is when two different parts of the code result in the same outcome, right? So the same outcome here is go to a new position. I've already put that here. So I can just broadcast new position from here as well as here. So it takes a new position right at the beginning. It also takes a new position when it touches the snakehead, right? So we are set that way. In fact, I can add, let's see if I've got this chomp sound. So just for the, purpose of beautification, I can add, say, I can start sound chomp. Remember, this is an event sound. It's not a background music. So I will use start sound. I'll say start sound chomp. Maybe I'll broadcast this position first. Start sound chomp. Now I will introduce a variable, right? And this variable will be called the score, right? So and this variable is actually very, very important. Make sure this variable is available to all the sprites. So far we have not gone into this portion at all. We are going to go there very soon, but for the score variable, please make sure it's available for all the sprites. So score variable is right here, available for all the sprites, right? So score is here. Now score is 0. So what we will do is that once the snake head touches the apple, which means, this condition, I can say change score by 1, right? So this is it's basically going to give it a score. And I can also, add a little bit of weight, which I always do, because we do not want multiple touch events to be registered. So, weight of 0.5 seconds seems quite reasonable, because anyway, this guy would have moved away somewhere, right? So half a second is just fine, right? Most importantly, right? Most importantly now, I am going to broadcast a message saying that I have been eaten, right? So remember, this is Apple Sprite. Apple Sprite knows when it has eaten this, right? So we could broadcast a message here telling everybody that, look, I have been eaten. And the primary audience for this message would be the snake body, because now it's the time for the snake body to start coming behind the snake. Remember, whenever the snake eats the apple, snake body gets formed right behind the snake head, right? So this is the time for it to happen. So we will broadcast a message. So I'll go to, events, and I'll broadcast a message called, let's say I'll call it eaten, right? So I'll call a message called eaten, right? And I will broadcast this message, and uh, this message will be used by the snake body to determine whether what it has to do. Right now, one thing you might be curious, why did I put all this code in the apple sprite? Why could I not do it in the snake head sprite? The answer is yes, you can very well do it in the snake head sprite. It will always remain the same. In fact, because we are using broadcasting for apple's position, probably this entire thing can go into snake head, it will not change. Only difference would be you have to be careful if touching apple, right? So I think it's either way, it's fine. But I just put it this way. Yeah, so you can choose to do it this way, to whichever way you want to. The important point is going to start now, and I'll take a break here at this video. The important bit is how will the snake body clone, right? And this is where the interaction of broadcasting, cloning, uh, local variables, which are variables only for this sprite, and finally the lists will all come into play, because snake body will clone. Snake body will also go to a certain position and make sure that it is following the snake head. So all the things are going to come together. Whatever we have done so far now will come together now in the next part of this video, right? So we will take a break here. I will see you again in the second part of this video. Take care. Bye bye.